We are going to get started. How many of you are new to Thai? Few. Okay, great. So I'll just quickly take a couple of minutes to give you a brief background on Thai and how Thai got started. So Thai was founded in 1992 by a group of highly successful entrepreneurs who came from a subcontinent, South Asia. So they wanted to give back to the community, and so they got together and formed the Indus Entrepreneur Group. And since 1992, Thai actually started here in Silicon Valley, and we had our first conference, Taikon, actually in 1994. It has grown to over 60 chapters, and I believe about in 18 countries worldwide. And it's a not-for-profit organization run very heavily by volunteers, a number of them, including our panelists, our co-chair for big data industry segment of the programs here, as well as a number of them who are here in the audience. I can see Saurav right here. He's our co-chair for sponsorships for Taikon, actually, and he's bringing the money to keep us running. So it's heavily run by volunteers, as I said. Thai's mission is to foster entrepreneurship globally, and that's what has been right from the beginning. So we create programs to help inspire, educate, and mentor entrepreneurs. And so what we have is a number of programs throughout the year. Main program we hold each year during May is our flagship conference called Taikon 2013. Taikon. In fact, you might have seen on the earlier that it gives you the link to attend Taikon. So, how many of you are attending Taikon? All right. So, how many? Let me do a quiz then. How many of you have attended Taikon since it started? How many Taikons have been held? Let's see who's Shakuntala Devi. I'm sorry. So since 1994, so it's 19, next year is 2014. Shyam, I was just looking at Shyam is figuring it out.
I was calculating.
I know. All right. So Taikon is really, for those who haven't signed up yet, please do sign up. I think there are some, if you need any discount code before April 30th, we should be able to get that to you. Ramesh over there has some of them. He's at the food count. He's our also director of business development for sponsorships. So it's a very electrifying event. We are doing this year, Taikon even format and structure is reinvented. What we are doing is basically on Friday, May 17th, we have 3 tracks about the big trends which are happening in the marketplace. As I said earlier, Thai's mission is to foster entrepreneurship, so we also try to design our programs around what's going on in the marketplace, which will be beneficial to the entrepreneurs. So 3 big trends, as you know, are mobility, big data, and then we have software-defined infrastructure, which includes software-defined storage, software-defined networking. And then on Saturday, we have again 3 tracks. The one major track is entrepreneur track, which has everything starting from funding, what kind of funding you should look for if you're starting a company first time, whether you should go to an incubator, angels or VCs, and then what kind of challenges as an entrepreneur do you face. So we have fireside chats with very successful entrepreneurs who've gone through these roller coaster cycles of startup adventures. And then we also have other tracks, a global innovation half-a-day track, which will bring even incubators from around the world. And there is also a new track this year, which is trends in professional services industry, because a lot of entrepreneurs, as you know, even from South Asia, they are in services industry. So please make sure you register. And then around the year, we do a number of programs around, again, the market trends. So we have big data, for example. This is our first program for the year, and we recently had one on Internet of Things, which is again, another trend for machine-to-machine communications, including a lot of mobile devices. As you know, in almost 15 years, as John Chambers says, there will be about 50 billion devices talking to each other. So which obviously means they are talking, means there will be a lot of data, so that means a lot of big data. which you learn from our experts anyway in a few minutes. So those are other programs we have. And then also we have, like I said, on the entrepreneurs, how we can help them. We have Thai Angels here every month. Those who are looking for seed funding can apply. So then again, they're selected, and 3 companies present in front of a lot of highly qualified investors, charter members. Then other programs we have recently launched is Thai Launchpad, which is more like an incubator for enterprise, targeted towards the enterprise market. And so that's on the programs. And then we have 3 stakeholders. One is charter members. How many charter members do we have in the audience? Can you please have? So charter members are very highly successful individuals, entrepreneurs, executives, and who obviously help support the organization and backbone of this organization in mentoring as investors and advisors. So please make sure you connect with them. And then we have second stakeholders members, which is open to everyone. So anyone can become a member for $150, and that it comes with all the programs will be free. They can come and have some wonderful meal over there, and then hear from the experts. And then third stakeholders are our sponsors. And so we have any sponsors we have here today, I guess. So a lot of, like I said, mostly Thai supported by sponsors, and Saurav is in fact sponsorship chair for Taikon, helping to make sure we can bring sponsors, a lot of sponsors to provide these programs at a very low cost. So with that, what I'd like to do is I'd like to introduce Karthik Kannan. He's head of products at Pivotal, head of products at Pivotal Analytics, which is a company. It's already a $350 million revenue startup. Disclosed. Usually startups don't tell their revenues, but looks like I read it somewhere. Yeah, I know. So you can start your startup with $350 million revenue. It's amazing. You can ask him the tricks. So anyway, before that, Kannan was founder and VP of marketing, product marketing for Status Software, which was a big data analytics firm and acquired by VMware. And actually, Pivotal Analytics is a spin-off of certain assets, I guess, out of EMC and VMware, which has been spun off recently. And I also noticed GE is now a minority stakeholder in that, because GE is getting into a lot of this machine-to-machine communications area. Prior to that, he was again one of the co-founders and VP of marketing at KGON, which was bought by EMC. And then earlier in his career, he was at NetApp, director of products. So as you can see, he brings a lot of wealth of experience as an entrepreneur. But not only that, he's been very gracious and kind to be our co-chair for big data, which we just launched. We are launching, actually, this is the first program for Thai for this year and for next 2 years. So he's also agreed to be co-chair for that, one of the co-chairs. So I really appreciate that very much. And as well as he's also part of the advisory board for Taikon's big data track. With that, I would like to give him a big round of applause for assembling a great team here. And
Is this live? Yeah? Okay. So thank you, Naveen. Those were kind words. So today what we're going to do is we have an interesting set of panelists. And since this is a smallish kind of an audience, feel free to kind of jump in with any comments or questions. I have prepared about 10 or so topics, and if we go through them, it's at least an hour's worth of discussion, maybe more, and some of these guys can talk. So it can be a longish conversation. We'll plan for about an hour, 10 minutes, and stop at about 8:15, and then we can jump into some questions. But in between too, if you have any comments or questions as we go along, just raise your hands and we'll be happy to take your question or comment. So I'm just going to name the people here. They'll do their own introductions, and I'll kind of give you my logic as to why we picked this panel's constitution. So Venkat, who's sitting right next to me here, is from eBay, and he'll tell you what sort of magic he does at eBay. One of the things that piqued my interest about what he does at eBay and why I wanted him on the panel is, eBay is a consumer company, right? I mean, we all know eBay. It's been very successful. And one of the more important things about services like eBay and Amazon is the strength behind their recommendation engines. Because when you buy something, it's really interesting to know what else you might be interested in. What are other people like you who bought the same product as you bought? These are extremely interesting things. And he was one of the key guys who brought together eBay's recommendation engine. He'll talk more about it. Samarth brings a very different perspective to this panel. He brings the use case perspective, and he's an expert in healthcare analytics. And he's got a lot of experience working with big firms, and he's with McKinsey. And if you can afford McKinsey, you're a big firm. And if big firms are spending a lot of money in big data, that's one of the most important things about big data is it's not just a fancy trend. It's not just two big catchy words. There's a lot of money going into big data with a production of a lot of results too. It's not just money being sunk into it. It's a lot of good things coming out of it. And I would love to hear some of his perspectives on the use cases behind big data. Right? And then we have Milind, who is, you probably have seen him on multiple panels. He gets around quite a bit, and he's an avid blogger and tweeter as well. So I don't know your handle, but you can give it in your introduction. So he's chief scientist at Pivotal. He came from a different background, and we ended up at Pivotal together. But he came from Greenplum and prior companies before that. His perspective is, he's a technologist primarily, but more importantly, he's a chief scientist. And you've all heard about the role of data engineers and data analysts and data scientists and scientists in general. And I'd love to get his perspective on who are these people, what are their roles, is it growing, is it a trend, is it just a fancy title? Clearly not, but those are the kinds of perspectives I think he can bring to today's panel. So with that, let me pass the mic. What I'd like to do is have them introduce themselves, as well as maybe a sentence or two, or take a couple of minutes to kind of give the audience a perspective about your role in big data.
Good evening, everyone. My name is Venkat. I'm the Director of Merchandising at eBay, which means I have technical challenge. Hello? Yeah. So I manage an applied research group, and the engineering group will talk more about why the two groups. The thing that fascinates me is this is like merchandising is a very it's an emerging area. Even ACM started Rexis pretty recently. There's not existing literature on how some of these things need to be solved. It's a hard problem. People always tend to compare us with Amazon and Netflix of the world. To some extent, I think they have an easier problem, but we look at it as more as a web search problem. How do you make sense out of unstructured information, and how do you correlate the transactions and the users and the items together? The reason why big data is kind of exciting to me is there are a lot of conventional wisdom that tells you, do things this way. I'll give you a simple example. Even outside merchandising, let's say it's spell check. Traditional literature says, use a Levenshtein distance. It's a dynamic programming problem. You have, computationally it's very expensive to do. Maybe it's n square and factorial computation complexity. So you waste a lot of CPU and computing. Edit distance, 1, 2, 3, and try to recommend build a dictionary, build spell checks. But if you look at places where you have high amount of traffic, could it be Google, Yahoo, eBay, Amazon, you can use the law of large numbers and statistics to your advantage. You can say, okay, people who typed in Britney one way, what did they correct to the next? And if you look at the aggregate about millions of people doing it, you find that you don't have to always have an algorithmic solution to some of these problems. You could have a statistical model that solves it. And why is a statistical model possible? It is possible because you have large amount of data to support and reach the statistical significance. So from that perspective, the world is changing. You're not applying textbook algorithms and models to some of these problems. And the next question that comes is, how do I make it computationally viable to process a large amount of data? And all of us will talk about it when that is. And that's when big data, how do I federate it, how do I process, all that comes in, map reduce and all of that. That's what excites me, is how do I reduce the complexity, how do I reduce the computational cost, and still power something which has high precision, makes and solves a real customer problem.
Good evening, everyone. My name is Samarth Kulkarni, and as Karthik said, I'm an associate partner at McKinsey. By background, I'm a biomedical scientist, but I've spent the last 7 years at McKinsey and I co-lead our personalized medicine practice at McKinsey. And over the last year and a half, as we've talked to observe various clients in pharmaceuticals, academic medical centers, hospitals, insurance companies, everything is gravitating towards data and in fact, big data. And we've done a number of engagements over the last 2 years. And in fact, Karthik was a panelist at one of the pharma companies who were considering uses of big data and what they can do for patients. It's quite a hot topic. At McKinsey, we've done a lot of research in the space, and people talk about the amount of money at stake, and our estimates in healthcare, where there's about $300 billion of value that's going to be shifted in the system through big data. Now, the other part of it, which people forget, and it's a big passion of mine, is you also help patients, you save lives. And in fact, people think only about the dollars piece of things, but people say that you could end up adding 2 or 3 years of life expectancy at the end of this all through big data, right? And number of diseases cured, a number of patients supported. Deep passion of mine because of that piece around patients. The second part is actually, the U.S. is now approaching 17% of GDP in healthcare, which is just completely unsustainable if you keep going forward. There's countries like Singapore, for example, that are 11% GDP on healthcare with much better healthcare quality. So we're looking at all those uses from the perspective of different clients, and so my comments today will be more from the use cases and what the end applications are, rather than the technology itself, not as deep in technology.
Hi, my name is Milind and I'm, as Karthik mentioned, I'm a chief scientist at Pivotal. I come from a high-performance computing background. My doctorate degree is actually in parallel programming. So back in 90s, and in fact, I was very lucky to have started my career at a government organization in India called CDAC, which was responsible for building the first supercomputer, indigenous supercomputer in India. So that sort of got me started in the high-performance computing area. And my PhD was in that area, and I used to work on simulating rockets. So the rocket engine, take that and you discretize it, and you basically simulate according to all physics laws, etc. So the model of a rocket used to be really small, but the amount of data by simulation that you would generate would be in petabytes, right? And at that time, we were basically using all these parallel file systems and all these expensive supercomputers. And fast forward a few years, when I started in Yahoo back in 2005, we were trying to revamp the Yahoo search infrastructure. Obviously, there was another gorilla in the room at that time, which was beating the crap out of Yahoo, if pardon my French. And that's why basically the executives at Yahoo were basically very concerned that our infrastructure won't be able to scale if we want to match that kind of data processing requirements. And that's why we started working on redesigning the entire Yahoo search platform. And obviously, Google had already published a few details about what they use internally, and we basically said this is pretty similar to what we want anyway. So we started implementing that. And over the years, we noticed that there was another project going on in the open source community called Apache Lucene, which was sort of an open source search engine effort. And at the core of that was a technology that when we separated it out of Lucene, we called it Hadoop. And essentially it became synonymous with big data. When people talk about big data nowadays, the first word that comes in that sentence is Hadoop, right? And the issues that we started seeing back when I started advising various projects, and that time it was called an applied research group in Yahoo, to move their projects onto Hadoop. One of the things that struck me was that people still applied that old mindset of sample a few data sets from these large amounts of data, build your models, and now deploy these models in production on a large amount of data, and they would fail miserably, right? So really bringing them onto this platform and making sure that they take advantage of the entire data that they have available and get their models deployed on models built on this entire data set, that really excited me. And so after working at Yahoo for about 6 years and taking Yahoo's Hadoop deployment for literally from 20 machines to a full data center wide. So when I left Yahoo back in 2010, there was something like 45,000 machines across 3 data centers running Hadoop, and this was what we used to call Hadoop at that time at Yahoo was that Hadoop at Yahoo was behind every click. So any click on Yahoo or any affiliate sites that you would make would have to pass through Hadoop at some time or the other, right? So that was sort of the stage, and then we basically started seeing uptake of. So back in 2009, this was sort of eye-opening for me that a little project that we have been working in inside of Yahoo and specifically geared towards search and related applications. Bank of America, 3 VPs from there on the infrastructure side came to us and basically says, we are evaluating this platform for fraud detection, credit card fraud detection, and all these other aspects of fraudulent transactions. And that's where sort of it was an eye-opening experience that this platform is now applicable to even enterprise workloads. When a conservative IT shop like Bank of America can think about deploying this open source software inside their IT infrastructure. And that's where sort of got me thinking. On the way to Greenplum, Greenplum is a massively parallel database that has been in development for the last 10 years. On the way to Greenplum, I made a brief detour in LinkedIn for 6 months and really wanted to, again, move away from the consumer side enterprise to business side. And this is where I think a lot of exciting opportunities are. I, as Karthik said, I get around a lot and talk to people. Mostly when I'm talking to customers, now basically their CIOs or their CMOs have heard that there is this thing called Hadoop. Get it in here, we are going to have a big data problem. So now they have one large Hadoop cluster and one big data problem, right? They still don't know how to migrate or move that big data problem or solve that big data problem using their Hadoop cluster. So that's what I do mostly in advising those customers. What excites me a lot about this space is this is just getting started. I think we are in an assembly language. I mean, if you've done programming, you would see that we were in an assembly language programming of extracting every bit of performance from these systems. But then it would take several years to implement even a simplest of applications, right? And that is the stage at which we are in big data. And I think this is just going to explode. There are going to be a lot of applications. Some of that I'll discuss in the panel discussion. But that's what I love doing.
Very good. Thank you, guys. That was a brilliant introduction, so everybody knows. And he's literally a rocket scientist, if you didn't catch that. So I've never really had a rocket scientist on the panel. There's always a first. So, we talked about a lot of things. I think a good way to kind of kick off the topics we have is setting the context of big data. Not really asking the question, what is big data? It's a lot of different things. But just give you a bit of context into, how many different dimensions there are in data. It's not just the sheer size of it. 2 days ago, we launched our company, the companies that Milind and I work for, Pivotal. And highlight was, Paul Maritz, who's our CEO, and Bill Rue, who's the Senior Vice President of GE, who's an investor now in our company, sat like this and they did a 10-15-minute talk during the launch. And one of the things was Paul and Bill bringing to bear the context behind big data, right? Why is it so relevant? Why is it so important? And I'll make it a quiz question. So Paul Maritz said, and he's been spending a lot of time with the GE aircraft division and other, sensory divisions. So all, this is the Internet of Things. So planes obviously generate a lot of data, right? So on a single 777 flight, transatlantic flight, every possible sensor on the plane collects data and logs it. Any guesses on how much data a single transatlantic flight generates? Anybody?
Yeah, I believe it's 10 terabytes.
You're in the ballpark. I wouldn't have said that much. Honestly, being in the space, I would have guessed a little lower. But it's 30 terabytes. 30 terabytes of data collected in one single flight. And,
now we could actually add to that. Virgin Mobile has added the peer-to-peer conversations.
That's
and stuff
right.
like that.
Yeah,
So
exactly.
it adds to another terabyte.
Yeah. So that's amazing. And the most important thing, and the reason I bring this up is not just the sheer size of the data that was collected, but you have to do something with all this data, right? So, because if you can do something with it, you can throw out maybe 20 terabytes of the 30, maybe you only need some of it, maybe you need to summarize some of it. So that's the context I want to get from everybody here, is what do you guys think about the dimensions behind data? It's obviously there is the sheer size of it, but since you have the mic, Milind, maybe you can kick it off. What's your perspective on big data? What is the definition?
So actually, Gartner has done a very nice definition of big data, right? But the parts of that definition that most people tend to focus on are, already everybody knows that. I mean, they talked about the 3 V's, right? The volume is just one part, but then the variety of information that is coming in, as well as the velocity at which the information has to be analyzed and absorbed. That is definitely, just one part of that definition is this, right? There are 2 more parts, which is basically using this information, using this data to generate timely insights. That's the second part of the definition. In a cost-effective manner. That's the third part of a definition, right? So you can. I mean, my experience with HPC, for example, is that you can build a multi-billion-dollar machine to analyze this volume of data and at the speed that you want, etc. But the big data technologies and the big data systems are really focused on cost-effective and timely deep analytics using that data. So that's the sort of thing that is actually not a lot of people tend to focus on, right? And that is where the systems are going in the sense that you earlier used to pay billions of millions of dollars in licensing proprietary software, buying proprietary hardware, or I would say custom built hardware, and implement your systems using that in a 3-year upgrade cycle, right? Now you're talking about enterprise infrastructure is moving towards commodity hardware. Open source, at least the core of the infrastructure software is all open source. Nobody goes for big fat, if you have to buy a new box, you don't go for a mainframe today. You basically build a cluster of commodity machines, right? So this is what we tend to call as the consumer grade enterprise infrastructure, right? So this is the new world, this is the new era, and that's where big data is basically flourishing in that the systems themselves are mostly open source, or almost all open source, and all built on top of commodity hardware. So that's sort of the technology side of things. But really making timely, deep insights using that data is going to require knowledge, which is not only the technology knowledge, but also the business knowledge as to what questions you want to ask from that data. So that's basically what I think big data encompasses, all these things, right from infrastructure all the way to the decision-making process that needs to get behind.
Karthik warned me that it's hard to beat Milind's answers because he is a rocket scientist. The only dimension I may add to what you said is for contextualizing the data, one big part, at least in the healthcare domain, is connecting different pieces of data. There's a lot of volume, there's a lot complexity, but unless you connect the different types of data from different machines, it's hard to contextualize it. And for me, I don't know, the technology that enables it is also part of that big data definition.
Yeah, both of you have done a good introduction to big data. So I'll just talk about the other side of big data. Since you have large amount of data, even let's say someone like eBay, we're generating close to maybe a petabyte of logs a day, out of which maybe 1 terabyte of logs we are mining. So there's a lot of information that is available. I think what is really also important, as you said, is the velocity at which you are logging this and the correctness of information. Do I have the right data points which I can analyze? You might have a lot of information, but there will all be noise, and you can't even make sense out of it. So how do you devise models and algorithms to tease out those semantic relationships between entities, which is important, which is also becoming a bigger and bigger challenge. The other thing is, how do I create a computing infrastructure where, let's say, you have 1 year of transactions, just in whatever company you're working on, be it Amazon, be it Google, or be it whatever. Like, how can you create a paradigm or an environment where you can effectively compute on that data set? right? So I'll give you a simple example. One of the things that I've always said is, let's say if you have to count all the words in a book, I can sit here, take a pen and paper and start counting as I'm reading the book every page by page. Or what I could do is give each one of you few pages and say, can you count the words in your pages? And I can put them together. I map the problem and I'm reducing it. So things like Hadoop are enabling you to do things faster on a large amount of data set. Right? Things that were not conventionally possible to do it on a single machine or maybe even on a mainframe, which were computationally very intensive, which would take days and hours to run. Now you're able to federate it across low commodity machines. Low commodity machines does not mean you go to Fry's and pick up a HP box and connect it together. That's not. It is you have a good amount of specification of what that needs to be, but how can I move the data and the computation closer together so I'm not trashing I/O, I'm not trashing. So there's a lot of engineering challenges that are coming up. There are a lot of algorithmic challenges that are coming up. How do you process this volume amount of information, even if I get 30 terabytes of data from the sensors? How do I effectively process, store? There's also a lot of literature that comes up and saying, is too much of information good? Maybe, may not be, but if you look at it from the machine learning point of view, you find that after some point, adding more signals is not going to improve your precision or not going to improve the information gain that you get. So how do I find the top K features that are good to compute? So that opens up another class of algorithms which says, how do I determine the top K class? And so from that perspective, there's endless amount of problems that come in. It's not just the data, like the compute infrastructure, how do you analyze, even traditional stuff, like even if you go to search, people know TF-IDF, term frequency, inverse document frequency. It's easy to look at it from a corpus of a document, but let's say I have to compute this on 1 million documents. Should I do it on one machine? How do I do simple statistical, how do I compute average across 1,000 machines? That's an interesting problem, right? You compute a local average, this group computes a local average, how do I put everything together? So it opens up a tremendous amount of possibilities, which is exciting. It keeps everyone busy because it's a foray into a new area. So there are a lot of interesting things that are happening, that are evolving, where people are questioning, okay, this is traditional, how do we make all of these traditional things work on a really, really large data set?
So by the way, that was a very good way to explain MapReduce, a very nice example of the pages being distributed out. So I'll pick up on one of the things that Samarth mentioned when he was talking about who should be driving these projects, right? So the way I look at it, big data and the whole problem behind crunching a lot of data can be manifold. There's technology involved. So I look at it as a technology problem. Vendors and startups need to innovate, right? I look at the scale of the problem, like 30 terabytes in a day. That's an engineering, compute crunching problem. So that's engineers and computer scientists, computer engineers. I can look at this as being an algorithmic problem. It's not just massive amounts of compute. It's how intelligent are your machine learning algorithms. So I can look at it as being a machine learning / scientist problem. I can also look at someone like Samarth and say it's a business person problem. I mean, he talked about something very specific. He said it's important to extract the relationships from within the various dimensions of data, right? It's not sufficient to know that I shopped on eBay. It's important for me to also know that such and such person shopped for these two products, and that combination is going to be a hit. So maybe I want to stock up inventory as a retailer, perhaps. So maybe I'll begin with Samarth. If you can comment on who should be driving this, and you see a lot of clients that you engage with. Who are you most engaged with?
Yeah, let me give a couple examples to illustrate the point. One of my clients is a pharmaceutical company, and what they want to do is manage the disease of patients while they're getting the drugs. So what they want to do is for cancer patients, they want to say, anybody who's getting drug from our company, we want to monitor how much they're walking every day, how much they are, what they're eating, whether they're taking the drug on time, etc. So they want to create sort of a portal and then attach things like Fitbit, apps on the mobile phone that say what they've done that day, what did they buy at the grocery store, etc. So they have the use case because they know that if they connect all these dots, they can warn patients and say, you know what, you're actually getting on your last cycle of chemo, you're going to experience some muscle ache and neural ache, and you know, be careful, right? So there's definite benefits that they've identified from the use case perspective, and now they're trying to say, okay, who should we hire? You know, how should we get this done? And it's really difficult because one, they got to create the portal to capture the data, and that seems like a whole different competency to say, how do you get people into this Facebook-like interface or something else, right? There's a set of companies like MedHelp and Healthline that are trying to do that with the patients. And then there's all the dimensions of then how do you actually analyze the data, build the algorithms, etc. And there, it's actually a real challenge in bringing all the data scientists together. So I think the other story is I've been talking to a lot of venture capitalists, and Rock Health has put a lot of money into big data, but a lot of them actually are not succeeding because they said, it's easy for us to do some of the other consumer type, app type startups because you get one scientist, one business person, and it's there. With big data startups, it's like you got to get a founding team of 6 people with different competencies, and it's actually really hard to do to get these people together. So I think the advice that we've been giving our clients at the big companies who can afford it is you got to get the organization in a way where the data scientist is talking directly with the business person. And if you don't have that linkage, then it's really hard. And then the data scientist can figure out what else is needed around that, like data capture platforms, etc. It's a challenge.
So when I talk to several customers who basically are at a stage where they are looking at, okay, what do I do with these big data systems? I think I sort of notice a trend as to how these projects get started. Okay, it's almost like in the context of Hadoop. Hadoop, I think, is the revenge of programmers against the database administrators, right? So they want access to the data, and the DBAs basically says, go away, come back in the next 30 days, then you will get access, right? And these people then basically say, okay, you know what? Let's not do it in the database. Let's pull the data out slowly out of that, keep it in a separate repository so that we can experiment with that, right? And that becomes a 2 or 3 people project, 2 or 3 programmers project, right? Now that becomes successful. I mean, they somehow talk to the manager saying we succeeded in this. We, the promised lift on whatever is 10%, right? How that translates to a business revenue issue, that's a different thing. But then the manager talks to the VP. VP basically goes talks to the CEO and says, you know what, these guys actually have done something. We need to productionize it. So now they sort of put some process around it and say, okay, now this is going to be serving data in a production system, right? And now basically then it grows, and suddenly those 3 programmers are not, I mean, first of all, they have learned Hadoop, and so they increase their salaries by 40,000 a year, going to other companies, and they leave. Or even if they stay, it basically does not become like a 3-people job to handle that large system. And so now it goes to IT. That now the poor IT people are basically faced with managing that. And that's where they essentially come to the vendors and say, can you give us tools? Can you give us small help? Because you have helped manage our IT, our IT is trained in your systems. Now what do we do, right? Now imagine if it actually came, and nowadays I basically see that most of these deployments start from the top, and then they also face essentially the same issue, right? That, okay, IT basically then controls as if it is their infrastructure, and then controls access to it, which means all the data is again, goes into the same DBA territory, right? So I think there needs to be a conscious business decision that this is the project that we are going to implement. These are the platforms that IT basically need to make it open to all the programmers or all the data scientists within this company so that they can explore them freely without having to go through, several layers of processes there. So this needs to, I mean, it probably, it's a cliche now, but it requires a change in the company culture itself, the business culture itself. Unless that is there, these big data projects are not going to succeed.
Mm-hmm. So I wanted to add some color to it in the sense that the expectations from people are even within the company. People are aware of the compute platform, the MapReduce paradigm and everything, or Hadoop installations across different organizations. You have a lot of clickstream data that's coming in, and we're in a world where the expectations have drastically changed from a few years ago. So we have business people who are demanding the business intelligence data, saying, hey, how fast can you figure out this feature that we added is actually doing well, so that maybe if it's not generating revenue, maybe we should turn it off. Like earlier, it was difficult. Getting those insights was very, very difficult in the sense you're querying data, you're writing expensive data SQL scripts. There's a lot of compute resources now with the MapReduce of the Hadoop the implementations. All these questions are easily answerable, and then people are demanding more and more of this information. You have experiments that you're running on the side. You want to say, hey, is it going south? How soon can I change course and bring it back in the right territory? Like some of these things which were done few days later, where you had the cause and effect kind of thing. Now you want to say, the expectation is saying, hey, how soon can I figure out something is going wrong? It could be alerts, it could be monitoring, it could be looking at the health of the grid in the data centers. It could be anything, or maybe all the deployments of of all the ATM machines, saying, hey, which one's running, taking out usage patterns and everything. So it's phenomenal that you are able to compute at scale and get answers quickly, so you can change course and still be successful. I think that is really, really exciting, in which you could not do with the traditional databases, with the traditional sequential execution systems. That's changing.
Right. And just to offer my viewpoint on this as well, I've talked to say a couple of hundred companies in the last few years just on this problem of big data and how are they solving it, what do they want to get out of it. I think, like the panelists said, it's a combination of many things that makes it successful. You have to have the right technology. When you're a smaller company, you may make do with some tools that help you crunch data. It doesn't have to be Hadoop all the time, but it could be. But more importantly, you need the right people who will use the product, who will maintain it. And then thirdly, you need the business and scientist community to make something out of it. Because if you really don't know what the data means to you, it's hard to get any intelligence. Not everything is completely programmed. It's not all statistical. It's not the highest number wins all the time. It's about the relationships. It's about what else happens. And then you get predictive, right? So I think there's a whole ecosystem. And somebody said this, I think it was Samarth who said this, you need 4 to 6 people to start a company in this space. That's absolutely right. That's exactly what we are seeing, is there is the business perspective. How do you apply this? There is the scientist perspective, there's the engineering perspective, there's simply the technology perspective. So it's a bunch of things, and which is particularly why I think this big data phenomenon that we are going through right now, much as people say, there's always been big data, there's always been terabytes, it's very different. It's really different now. That is why it's just not about the buzz or a trend. It's real, right? And there's real life implications. It's saving lives, making planes fly. All the battery problems with the Boeing were really analyzed heavily. There's smart cars, and we have a company that we're talking to as a customer who is doing a completely electric vehicle, and it's completely smart in that it's sending all kinds of sensory data back, and that information is really key to fine-tune this new emerging technology. And I'm driving a Prius right now. It's a rental because my car is in the shop, and every time I stop at a light, I wonder how they make it such that it starts when I press the accelerator, because it completely shuts off. And there's this nice graphic on the panel, if you've observed, where it says when it's drawing power from the electric engine and when from the gas. And when you build a complete new brand of vehicles, and this is really consumer proof, right? Because you have all kinds of people driving cars. People who could really drive versus people who in Cupertino just cannot drive, right? So that, when you build a car like that, you need all kinds of sensories kicking in. So this electric vehicle is sending sensory data. And that is what people are referring to as the Internet of Things, really. Or as the GE CEO, who was also on our launch, said, it's the industrial internet. Meaning everything is, contains a sensor. And it can potentially send data. And consider someone like GE. They have data coming from airplanes, they have data coming in from your refrigerator. And if all of these are really instrumented and you have the right technology, you can mine this really well. How often are people braking their cars? Braking as in pressing the brake pedal. How fast are they going in traffic? And these help build a better car, right? It's a practical use case.
Can I ask one question?
what is the key driver here? There was a business problem, the technology was not available, so that's why big data is exploding.
I'll give you my really quick
Or
perspective.
basically there was a, now we have the technology, companies are looking at, hey, how can we solve the business problem? Which is the key driver?
Yeah, I think it's a chicken and egg argument. I'll give you my 30-second answer to this one. The way I think about it is technology certainly is the enabler, so it can help you do more things. Just before all of this happened, there were various industry analysts who put out statistics about what percentage of an enterprise's data is really mined. And often the number was 2, 3, 5%. And that's really, per IDC, let's say, 5% of an enterprise's data is mined for information. Now, it's a competitive advantage to know what else is stored in the 95%. Where are your revenue streams? Where's your competitive advantage? And these were things that you simply couldn't tackle before. And I think technology is certainly enabling the tackling of that problem so you can identify new things quicker. If I were not able to distribute those 10 pages to all of you, I would have never been able to count the book's words. But now I can. And with knowing that I can count it, I can think of use cases now saying, hey, what if I knew how many times that same word recurred? Maybe I'll create an index out of it, right? It spawns new ideas. That's what I think. So technology is the enabler is what I think. I'd love to hear what the panel.
I think the big data problems always existed. I mean, the way the big data was defined before was that the data that you could not store economically and could not analyze in a timely manner, right? And that always existed. People used to, the whole enterprise data warehouse basically came about because we were gathering all this data. You would do a costly ETL process, right, to see which data you should keep, which data you should throw away, and only the necessary tables for your business use you would keep in that EDW, right? Now you can basically see that rather than throwing away the data, and this is the technology enabler, that technology enabled storage growth that has happened, that rather than throwing the data, because you don't know what questions you want answered from that data today, you might get a new question tomorrow, and by that time you have already thrown out that data. How do you answer that question, right? So that is why just keep the data for a while until at least your regulatory compliance is not violated, right? As long as that is not done, just keep the data so that when you have the technology, when you have the real business use case, you go back, answer that question using that historical data, right? So that problem has always existed. The technology has enabled to sort of stretch it and answer new questions. That's pretty much what I would say.
Another sentence, I think. To what Milind said is really true. I think a lot of times you have finite amount of storage in most of your enterprise data warehouse. You don't have infinite storage. So let's say even for things like eBay, let's say if I'm looking at clickstream data, the browser, the user agent is very important. Maybe someone will say, hey, that's not an interesting piece of information. Let's chuck it. And sometimes maybe that's valuable. Maybe you want to know, hey, is this bug occurring in Firefox? Is this bug occurring in Safari? You don't know. I think that's a very valuable piece of information. So how can you store the information, compute at scale? I think for me the biggest thing is, as you said, the big data problems always existed. This there's a new approach to computation. Not new. I think it's the commodity hardware and the infrastructure to use commodity hardware to compute this. I don't know how many of you are familiar with the SETI screen saver. It's been going on for a long time. Right? They were really, really smart, ahead of their time, trying to use your local CPU to compute, all the sensor data they're getting from the extraterrestrial signals. So that was like the first time where you're federating and computing. Right? It's not something new, but now you're able to do it with a rigor in an enterprise, deploy it, manage it, do it in a repeated fashion, which is what has changed. But the biggest thing that has changed is the expectations of people. We all have now bigger expectations. You want instant gratification. You want something, you go to a website, you do something, they want you to recognize what you did right away. Right? They want you to say, hey, I bought, I'm watching action movies, so you better show me the action movie. So how do you power some of this? Right? In the digital world where everything is connected, your expectations are that whichever be the company, mine all this information and put it together. Right? So that is also one of the biggest driving force which is forcing you to think through this. Like when you earlier had the online presence, all these expectations were a little diminished. Right? Now that has changed.
In healthcare, it's the chicken and egg has another dimension to it, which is that there's data available now. Yeah, 5 years ago, there were 250 petabytes of data in hospitals, but all in paper form, so nobody could analyze it. And now it's all in electronic medical records. And then genomics. 5 years ago, it cost $100,000 to sequence your genome. Today, you can leave your fingerprints on the glass, and for $1,000 you can get your genomic data, right? And that's adding a lot of data, which is actually enabling people to do big data in healthcare.
I'll add one example of this not throwing away the data, right? I mean, you mentioned what browser user agent that people have. Orbitz, which is the travel site, they basically recommend you the hotels after you have booked the flights, based depending on. So they used to do this sort of based on intuition, in the sense that if you are going to Hawaii, you're typically going from the mainland, you're going for a vacation, which means you can spend a little bit more there. So they would show you the sort of the higher range hotels, right, when you go to Hawaii. Well, they basically just then they didn't throw away all the other data that they used to have, and they just, some data scientists in there basically decided to see how does the choice of the machine or the browser is affecting this. So Safari, which worked that time only on Mac, versus Internet Explorer, right? They found that the Safari users were more likely to spend more on hotels, etc., than Internet Explorer, right? Now, if they had thrown this away and did this into, when they brought this into the EDW, they would never be able to take advantage of this personalization, that if you are browsing Orbitz from, or searching for deals from, on Orbitz from Macs, then offer them a higher priced hotels, right? And obviously that translates to the actual revenue being generated for Orbitz, right? So this is one of the examples of, business use or business questions are there. You haven't yet thought about asking them. You have to keep historical data in order to gain more value.
And I want to just add to that example. First of all, now you know where to go book your tickets from. Right?
Always use Internet Explorer. You get cheaper cost.
Yeah. Or Firefox, or something open source. So the importance behind this example is really, and this goes back to the answer to the question. A database and a data warehouse in the traditional relational world is only as good as the query is, right? So to Milind's earlier point, if you knew your business and you knew what to ask, you get a result. And that is not really the problem. I mean, there could be a crunching problem. If you had a 1 billion row database and it's going to take some time, you got to fine tune your SQL. But then again, you're relying on the intelligence of that business analyst to ask the right question. And the question may be, how often are red-colored, Toyota Corollas getting into accidents? Well, you knew sort of what kind of a question to ask. What if you had no clue that there was a relationship between browser type, which is a very standard thing that all Apache weblogs, any web tracking, click streaming application tracks. But if you didn't know to query the correlation between your vacation rentals and the proclivity to pay a higher price and the browser type, you would have never gotten to the answer. However, a big data and intelligent machine learning algorithm driven system can automatically surface up the trend to you, saying, hey, did you know that your revenue is positively attached to these attributes? And then you have a better vision, right? And so that's clearly technology enabling a business person to think more and say, well, that gives me an idea. Now I can go do something. So these are actionable insights that you get out of your data. So I was going to bring up a topic about real-time, right? I mean, there's real-time analytics, and there's a lot of real-time in everything. When I was back in college, there was a real-time information system. That was 20 years ago, and I had no clue what I was doing with that as a project. But real-time is really, is real, right? I mean, there are real-time applications, there are real-time systems. But when it comes to analytics, and I want to hear your opinions, guys. I mean, in a place like eBay, I can understand the importance of real-time. Would love for you to go through an example. But in your respective worlds, how important is real-time?
Yeah, I think real-time is one word to think which is different to different people. So if I go ask someone who is running a distillation column or some industry where they want instantaneous, the boiler pressure is increasing, I want to shut it down. So if I look at it from eBay and look at it from a lot of e-commerce sites, real time is not that real time you want, right? There's lack of information that is acceptable. Hey, maybe you bought a phone. Maybe I figured out that you bought a phone maybe 2 days later, because traditionally you realize that maybe you're not buying the accessory the same day you bought the phone. Right? Maybe you can mine this information. But there's a different class of problems that also people are looking for, in the sense that how can I get analytics on the features? How do I know when things are going south? How can I detect trends? Let's say Oprah comes and dumps her entire wardrobe on eBay. How do I detect that, how do I detect the rising edge? You can always detect an edge after the trend after it has happened, but how do you detect it really fast? So that is kind of almost...
Our one example could be the other day when there was a posting on Twitter, right?
Right.
So that could be a real time, I guess.
Right. So even Google has started the real-time index of using Twitter feed to show on the Google search results. So there's different class of applications which demand different SLAs. Traditionally, on most of the e-commerce side, you can have a relatively bigger delay. For example, let's say you set a preference. Maybe I can take 50 milliseconds, 30 milliseconds, or maybe 2 minutes, or maybe 10 minutes to go update my backend systems and for the index to refresh and show up. Maybe it is not causing that much of an impact. But if I go do it on a boiler pressure, you cannot wait that long. Things will just go kaput. So I would look at each application to see what is your tolerance between mean time between updates when you require, and then engineer systems that way. Because it's very easy for me to over-engineer a system and then come back and say, hey, I need real time, and you find that you probably might not need real time. But one place which is coming up, which is evolving pretty fast, is the complex event processing, where you're trying to do a lot of this, the streaming of events in memory, and where you're getting doing a lot of computations in memory really fast. How do I do, not just do random sample, but on the actual 100% sample in memory? Like, how do I stalk you in a session? Like, how do I know what you're trying to do? Hey, maybe Bala is trying to buy a digital camera, but how do I cannot detect that after he's left the website. I need to know that he's doing it, he's there on the site, he's doing it, so how do I compute that? It's a hard problem, because if you look at, there are maybe 100, 200 million users who are active on the site, and you're getting tons and tons of this information coming through. And how can you compute at scale? So you can just imagine storing this information for efficient retrieval and building the session graph on the fly, and then probably computing, saying, okay, all your queries are actually alluding to the fact that you're looking for a digital camera, so maybe I should start showing you the top digital cameras. Can we get to that state? Right? It's important. So we are not there yet, but I think that's something that we are looking at. I hope that's...
I'll give you a couple examples. One is a pseudo healthcare example, one is a real one. How many of you are John Grisham fans? Okay, not many. More people are going to Taikon than that. But we were at another panel and we were discussing what does real-time do in healthcare. And John Grisham writes a lot about ambulance chasers, lawyers, or putting their offices near big intersections so they can find car accidents, right? The new ambulance chasing is big data. Literally there are the websites, John D'Souza's CEO of MedHealth was saying he noticed a lot of activity among women who bought, about certain skin problems in a certain segment, and he was like wondering what the correlations were, and they'd all had Victoria's Secret purchases within that population, and he was like, gosh, something's here, right? Then they tracked this back to one factory of Victoria's Secret that made certain bras that caused skin problems, right? And so that's one example. You're going to find things that go wrong in the healthcare system. It's going to be big for lawyers. Now, that was the not so serious answer. But in healthcare, real time is extremely important. 46% of patients who have congestive heart failure are readmitted to the hospital in 30 days. And a lot of them have really bad outcomes. You know why? Because they had a big meal, they forgot to take their medicine. Simple things like not, too much salt. And with Indian people, it's actually even more acute readmissions. And so if you have data like the machine-to-machine learning that you're talking about, which is this person went to Safeway and bought a lot of salty stuff, right? And there's the drug monitoring which says, oh, they forgot their pill today. Send them a warning right now because they're going to be admitted in the hospital, right? So there's lots of reasons.
So it's more of a behavioral solution rather than a big data solution there. The use case that you're talking about.
No, but I think you need big data to contextualize all that and make sense of it. Otherwise, you know, you're not able to connect the dots.
Yeah, you're talking about 1 million patients and 1 million actions per patient. So the problem becomes exponential, right? And Venkat and I were talking before the panel, and in fact, during his introduction as well, he was talking about how things can be an n factorial problem very soon. It's like having a combination lock with 4 digits, and quickly it's a factorial problem for you to solve that. So that's where the big data comes in. Milind, back.
So real-time is not important, real-time analytics is not important if you cannot make real-time decisions. That's the thing. I mean, if you're basically waiting for somebody who's the highest paid person in the company to express his opinion about what he sees from the analytics details and then take a decision, that's not real time, right? Then for that you don't need, for that you have had the dashboards, the nightly reports generated, that you have had already, right? What you need real-time analytics for is basically exactly the use cases that you described, that before this person leaves my website, I need to make a decision, and this is all automated. It's not that somebody is basically sitting and monitoring the session of what this user activity is doing. So unless your decision making is automated, you cannot, you don't benefit from real-time analytics, right? And the definition of real-time, as you said, 1955 was, I think, the first real-time as a definition came in.
That was not when I went to college.
This is just going through this history of real-time, and there is a very nice article back in 2006 about how the word real-time has been misused, right? So the crucial part of the real-time definition is that there is a deadline against which you are executing, right? So whenever the data comes, there is a deadline on which you have to act, by which you have to act, and therefore that's the definition of real time. And most of the times it has been used in weapon control systems. Obviously, after the rocket goes and hits somebody else, then you can't analyze data after this saying that, okay, where should that rocket have gone, or all those kinds of things, right? You have to analyze that before that. So that's where it was mostly used because the deadline was already known. Now, in the case of machine-to-machine communication, even if you say that your Prius or the new Ford Fusion has something like 70 sensors that are collecting more than 7,000 streams of signals, but most of those are obviously going to have to be acted in real time, right? Your brake, you push on it, you basically you're reducing the flow of fuel to the engine. That has to happen in real time, right? That is a deadline that you have to hit before somebody goes and hits the car in front, right? That's basically the thing. But then there is a historical analysis of data that needs to be done in order to analyze patterns, right? Even in the websites cases, even in the consumer-facing websites cases, if you only depend on the real-time data that you are getting and the decisions based on, let's say, the last 2 minutes of usage, you are going to miss a big part of the signal. Because most of the things that happen, for example, what you buy on eBay during, let's say, Halloween, is not the same thing that you buy during Christmas, right? And if you have thrown away the data for last year's Christmas as to what your buying pattern was, you won't be able to give that person appropriate recommendations based on just his last 5 minutes or last 10 minutes of usage there, right? So real-time analytics is important, but needs to be combined with the historical analysis. That's what I would say.
Yeah, and in fact, just to add to that, that's what makes the big data dimension as well here is, it's not just the current shopping behavior. You have to go back and do a join with your past history and perhaps your profile information. I'll give you one of the examples I've encountered myself. Do you guys know this company, Jose Bank? They're a clothing store, Jose Bank, right? So they're famous for these buy one, get one free, buy two, get three free type of deals. So I made the mistake of going there once and putting myself on some kind of a register. So for the next 2 weeks, most internet sites that I visited had a Jose Bank ad cropping up, right? They're pretty good at that, right? I ended up buying something there, and you know why they sell you two things? Because once you buy from there, you're never going back. So that's pretty much all they are getting from you. So they want to sell you as much as possible during that first time. But that's a perfect way to capture somebody's audience. I mean, somebody's attention especially a consumer, right? Because everybody now today is a consumer, whether you're an enterprise user or not. It's like, when they said an iPhone is a consumer device, not anymore, right? It's an enterprise device. So everybody's a consumer, which is why, our CEO often refers to, the effort is as being building a consumer-grade enterprise. So there are the realities of real time. I mean, you have to have certain real-time things. But I'll go back to one of the things Milind said too is, unless you can take a real-time decision, like presenting a coupon when I'm on your site, or helping me buy something or recommending something, or somehow taking an action, real-time is no good. I mean, it's good to have that information, but what good is it if you're not going to use it? Right? So I know we're drawing up to 8:15. We have a few more minutes. So 2 things I wanted to cover. One is any favorite use cases that you would like to talk about. I know I've heard Venkat mention, your recommendation engine, and I would love for you to share that with the audience about the one you talk about how when a couple of years ago at eBay, when you bought a phone, you'd get a certain set of recommendations, and now you changed it. As you're going through that, I would love for you guys to kind of think of some use case you've encountered that you would like to share, right, as an example.
Right. So I think one thing we spoke about in one of the search meetups is there's conventional wisdom, there's conventional theory that says, collaborative filtering, just look at, buying patterns, people who did this also did that, people who bought this also bought that. And if you apply some of those conventional techniques without understanding the underlying data, you're going to get, garbage in, garbage out, right? It's going to get something. Eventually what we found is everything is connected to an iPhone, right? So somehow a lot of people statistically are buying a lot of iPhones, and all the correlation goes up. And you buy a phone, and you see, maybe we should be recommending more phones to you. But that's what the data is telling you. I'm doing simple collaborative filtering on what people bought. Immediately after buying this, they're buying more phones. But then that requires a lot of analysis. You have to explain, right? If you see a problem and you cannot explain it, that's when you deep dive and say, hey, why are these correlations coming through? And you find that, hey, there are too many resellers on eBay. They're buying phones after phones. Maybe that's what is skewing the result. So now how do I detect that, hey, Bala is a consumer, he's not buying, when he buys a phone, I should actually give him more accessories and not another phone, and versus someone else who is, really buying phones after phones. And you are able to analyze all this by looking at their, as Milind mentioned, looking at their historical transaction, their trends by category, and some of that is really important. But one of the good examples in merchandising that we always talk about is there's this question about all of us are very opinionated when it comes to talking about a problem. Is let's say you came to eBay and you lost an auction for a blue iPod 16 GB. If I do a quick sample across the room and I say, hey, what should I recommend back to you? Should I recommend more blue iPods? Or should I recommend a red one, which is comparable in price? Or should I recommend a silver? Or should I recommend maybe color is irrelevant? Or maybe should I recommend upsell you? Should I cross-sell? I don't know. So I could go to a bunch of the business folks and they might have an opinion, and someone will say, hey, similarity means it has to be exactly color. Color has to match, size has to match, and everything has to match. So we set out to try to, when my group was really formed, we said, can we answer this using the data that people are using, the buying patterns of the users on eBay? So to some of the point that we mentioned earlier, this was a perfect case where we had data, we never had this query before on how to analyze. Right? Now I have a problem, I want to query the data in a totally different way. I want to see if you viewed an item on eBay, what was the next item you viewed? And what is the next item you viewed? What features of the items are you keeping constant and what features are changing? Maybe you clicked on a red, you clicked on a silver, you clicked on a blue, or maybe you clicked on 16 GB, 32 GB. Can I look at this at per user? Can I look at it at the aggregate level? And at the aggregate level, the patterns will emerge for a typical eBay user. And then can we use this data to actually define similarity? Like what features should go into similarity? Is it token similarity? Is it attribute similarity? Is it category similarity? Or is it a weighted function of all of them? Right? That was interesting. It opened, and then the proof is in the pudding. Now nobody can come and argue and say, hey, similarity in eBay is a blue iPod is a blue iPod. Right? You cannot say that. Now you say, hey, this is what users at eBay want. Right? And big data, the processing on the historical data, processing on data at a large scale is teasing out these correlations. It's helping you even define requirements to a problem, not just find a solution. Right? Now you know what is similarity. I can define similarity, then I can go define a probability distribution function to go predict, how similar these two vectors are, or maybe is it a two-dimensional or n-dimensional space? I don't know. So all those things can come out. So one of the other interesting things that comes up is you look at the problem of personalization, right? Yehuda Koren, and there's one more researcher at eBay, his name is Madhu Sarwai. He's one of the most cited researchers in collaborative filtering. So if you look at personalization, let's say if I want to build a personalization profile, typically a lot of us will say, hey, maybe you know what, the geography is important. Maybe I need to find out your geolocation. Maybe I need to find out your shopping behavior. I need to find out, how much money you spend. Or maybe I need to find out at what time you are. So there are some finite amount of features that you can think of as a human, and then you will draw it and say, let me pick this makes sense. But does it really model the profile of the individual that you're trying to model? We don't know. You create these 5 features and say, hey, geolocation, and maybe his wallet size, and maybe the categories he shops is an important profile, maybe that's what I should do. But interestingly, the way the world is evolving, because expectations are changing, there's so much amount of information about you on the internet and online and offline, you expect the system to use all those signals to create a more personalized experience. It's a hard problem. People will work on it for years and years to come. But the better approach that people are trying to do is say, I don't want to even guess what your profile looks like. Maybe it is not even in a human readable form. Why don't I give all these maybe 1,000 features, give it to an algorithm, maybe it's a metric factorization problem where I say, I don't even know what those features are. Go figure out what should be the top key dimensions to build the profile. And I'll just use it. Maybe I can't even explain it to the user, but that will probably model what you are or what you mean in that system, right? These are the things that we're trying to do, trying to analyze where traditionally, it's our gut check saying, hey, this is how we're doing it, and these are the 5 things, maybe East Coast bias and West Coast bias are important. That's a data mining problem, right? Where you're looking at the histograms and the buying patterns to say, oh, based on statistical correlations, I think that is important. But maybe not. Maybe that is not modeling you as a user. So that is an interesting example from merchandising perspective where we can personalize the experience, define similarity, which was very good. But there's one more use case from probably from search. I think this is the same probably even Google or Yahoo is trying to say is it becomes a little bit of challenging for eBay in the sense that I have auctions, I have fixed price items, I have folks who have a huge amount of feedback, folks who have just come into the system. How do I give everyone a fighting chance, right, in search and still keep relevance to the query? Should I create a ranking function which is ranking the results manually? It seems like a logical thing initially to do. But if I have to use features that I can't even comprehend, like to some extent, like for the scientist who was in orbit, he would have not even guessed that the user agent was important. Like, how do I come up with these latent features conventionally you're not even thinking, right? So we spend a lot of time creating, probably applying machine learning to ranking, where we don't even want to know what features are being used. We don't care, you have feature 1, feature 2, feature 3. It might not even be human readable. It may not be called geolocation. It may not be called your phone number, right? So that's what is exciting. I think that's where some of the problems are being solved, where conventionally there's a conventional wisdom that says go this way, but when you use the data to your advantage, you find that the solutions might be different. And sometimes maybe I don't want to know what the solution is as long as it works. Even like, for example, bioinformatics, or even for DNA sequencing. Some of the problems that are there are saying that maybe the correlations are not something that you can add as heuristics, but you want the system to find out what are the correlations between the two, the constituent elements of the DNA. Right? So
what was the answer? Was it blue icon or?
no, so I think one of the things what we found was, thanks for asking that question, was the analysis led us to build a dictionary which said by various categories on eBay, we could actually rank features, say, hey, is color important in this category? Maybe on the iPod, we could say, now color is no longer important, whereas in clothing, the data told us color is important. So now we could score these tokens, we could score these attributes, and then use it. No, color wasn't an interesting dimension to keep constant.
So you can sell your iPod on eBay now, no matter what color.
I'll do a very quick one. One of my the pet ideas or use cases, I believe one of the fundamental problems with U.S. healthcare is people don't take responsibility for their own health. Okay, so if you take car insurance, right? If you have a fast car and you're driving really fast and you get negative points, you're paying more insurance. I mean, you're paying for your actions, right? In healthcare, you don't have that. What if you created a system where through big data, you can connect the dots and say, this person has a health score. They're buying organic food or something very healthy. They're going to the gym X number of times. They're modeling their lifestyle to be healthy. Then they get a better premium, right? And if not, they pay more for it, and they're aware of it. So that's the big data challenge that I think could solve a lot of problems in the U.S. healthcare system. I don't know how to do it, but.
So both my favorite use cases are to do with anomaly detection, actually, and both in the financial space. So one of our customers, very initial deployment, basically they had to do essentially fraud detection in stock transactions. Now billions of I don't even know how many billions records they get. But at the end of the day, and based on the last 3 months or 6 months of historical data, they basically have to determine certain number of transactions or whether those are sort of anomalous transactions. And obviously, they don't go and immediately issue arrest warrants. They basically pass it on to the federal regulators, and they basically look at that. There is still a human element involved, but rather than the federal regulator, the humans, actually going through billions of stock transactions every day, they now get a fair chunk, maybe around 1,000 transactions that they can look at and basically say, okay, does it appear to be somewhat of a fraud, right? And that resulted in some really high-profile arrests among the Indian community, in fact, some of them. So that was one of my favorite use cases. The second one is obviously our nemesis IRS. Uses the models now. So IRS, for a money collection agency, a budget, revenue collection agency for a government, it actually itself has its budget actually getting cut every year. It's not growing, right? And so the number of audits that they used to conduct actually dropped, if you remember, from maybe 1:10 to maybe now 1:50 or something like that. But then when they say that it has to be 1:50, now more targeted detection of certain records or certain tax returns that you need to go and audit, that is being implemented by, actually the models are developed by SAS in order to do that. And unfortunately, our database is used. So if you get audited, don't blame me. It's the SAS models that are actually doing this detection. But that has worked out very well, and now they can actually they after the SAS deployment, they basically were able to show that even with 1:50, the success rate that they are having to actually have a successful audit is even more than when they used to do 1:10. Right? So those are some of my favorite use cases.
Yeah, please go ahead.
So I think Milind brought an interesting area of the anomaly detection and fraud. So one thing that you have to visualize is, let's say you're Visa and you're trying to detect fraud. You have like millions of transactions that are happening. Fraud is not happening at the same rate as regular transactions, right? So from the scientists' perspective, it's a really hard problem to find out how do I actually detect that fraud. Right? The number of fraudulent transactions are usually much lower than the real fraudulent when compared to this. Maybe in 1 million transactions there's one fraud. Right? So you have just one data point. Can you generalize using the data point? Right? That's a hard problem. So even though you have volumes of data this is what keeps the machine learning guys really, really excited is how do I reduce my false positives? What features should I use in detecting fraud? Right? So it's a very, very exciting, interesting area if folks are interested.
So can we strike from the records that he said Nemesis and IRS? We do not want to get audited here on the panel. So we heard the perspective of a scientist, a business person, a technologist, an engineer, and some from a product and marketing guy. So hopefully that was a useful discussion. We've come to the end of prepared topics. I mean, there's a couple more we could go on, but I would love to see if there's any questions. And please use the mic so it can get recorded too.
Good evening. I think one question I want to ask you is that in all the different kind of models that you said, how important is like reusing the data? Like say you put a recommendation, and like he said, you buy a phone. There was a recommendation of another phone. How important is the feedback mechanism that this thing failed? So how do I put that in my engine again and use it for recommendations?
I'll just ask something. So actually, I would answer it from the area that I'm most familiar with, which is showing ads on search results. Okay, so the click stream, which is actually the ad was clicked, right? That's a fairly small amount of data, right? 1% or even 0.1% of the ads are actually clicked, right? Even less than that. But really, the ad was shown and not clicked. That also is a very important piece of data. That the ad was probably not relevant, and that is used very commonly in determining to improving your relevance algorithms and to provide similarity, etc. So this negative sort of feedback loop is also very interesting.
So I think the feedback loop is very important, especially for some of the machine learned models. For example, you always end up in this self-fulfilling prophecy problem where, let's say if I skew the system one way, it's always going to stick. So what you want to do is collect the feedback, recalibrate your weights, or even if you do some perturbation on X% of traffic, you want to say, hey, is the relationship still holding if I change it? Right? If I say color is not, now let's say if I just inject into the system, color is an important dimension for similarity. And then you find that maybe it is not, maybe it's not impacting the purchases. So okay, I've calibrated my system again that hey, color is good. So you can do these perturbations, so that feedback loop for most of the machine learning systems is important. But what you find is a lot of times people do these offline models and that model lives forever, it doesn't get recalibrated. That's when the systems tend to skew in one direction, right? So it's important, depends on the class of problems that you're trying to solve, and also the negative information is very, very super critical.
I want to take this conversation one level higher, from anecdotes to where do we go from here. It seems to me, given that the word big data really means data that is not really manageable by human means, that this technology is moving rapidly towards machine learning, not towards anecdotes of examples that humans can solve, one-off. And where the human comes in, ultimately, I guess, is in recognizing the pattern that the machine learning algorithm has produced. I'm guessing that it should end up, I know a little bit about how hedge funds work, and one of the common perceptions in the financial industry is that they've mined that data so well that people are now seeing patterns where they don't really mean anything. We haven't gotten there with things that are outside of Wall Street. So is that where the industry is headed? All towards machine learning and recognizing patterns rather than having humans involved in making decisions?
So I can take this time. So I think it would be, it would be wrong to assume that machine learning will solve 100% of all the problems. You can create, PDF or probability which always give you a score of 1, right? If you do that, probably, that part of research probably will just stop. I think what happens is you use machine learning to your advantage to jumpstart or to get to some level of precision. Let's say, I'll give you an easy example. Let's say I'm trying to do recommendations on eBay, and I find that typically if you go to the retail store, maybe next to the beach shorts are the sunglasses. But maybe people are not buying beach shorts and sunglasses on eBay, right? That day, even how much ever hard I mine, I'll never get that information at all, because that's not the pattern that people are doing. But from the recommendation perspective, that's something that you want to inject. So no matter whether you use data mining, statistical correlation, or even if I do machine learning, these patterns are not going to come back. So it's always a blend of domain-specific knowledge that gets injected into the system, which will boost the precision. Maybe you're going from 70% to 80% to 90%. And how do you create this domain-specific knowledge in this ensemble of these technologies to reach that? I think you're using machine learning not as a solution, but as a means to reach an end. It's going to vastly jumpstart the problem space. Right?
Yeah, the one comment I would make is, there is going to be a lot more machine learning, but understanding where the value is created and then putting it into the delivery system, whether it's care delivery in healthcare or whether it's in the workflow for something else, that will take humans and entrepreneurs and smart people to figure that out. Because otherwise, you're relying on random hits for success of something, right? You have to recognize the value creation aspect.
I could add just one more. Yes, I think machine learning is an important technology, and is going to be incorporated in most of the products, right? Whether it's on the back end or it's on the front end in the real-time system, right? But there are obviously limitations to machine learning. After all, you are limited by that probability factor, right? You need to, first of all, have this intuition that you can verify with machine learning, right? That is the most common application. And then to sort of verify whether your intuition worked or not, you have to do A/B testing, right? You basically choose random 30 people and show them something, and the remaining people show them something, observe their behavior, and then choose one or the other, right? There's probably, almost every consumer-facing website today essentially has some form of A/B testing going on all the time, right? In the extreme case, Google has something like 300 experiments going on simultaneously, because they have billion users coming on their site. They can partition the user segments accordingly and show them different things, right? The only product that I know has been extremely successful without doing A/B testing or whatever is this thing in my pocket. This was completely a vision of one person without going through any machine learning. But not a lot of examples like that. So I think it's going to be important. But then the power of serendipity also you cannot ignore, right? Just to give you one very concrete example, in Yahoo.com, the front page, we used to basically show that today module that you would see a few news and few videos, etc., based on your past visits to the site, right? Suddenly, there is a 2 o'clock. There is a news that Michael Jackson died of drug overdose, right? Nobody in the past 3 years has probably even clicked on any Michael Jackson news, right? How do we make sure that we have this breaking news? We actually make this relevant that people might be interested in. No machine learning, no pattern recognition is going to be going to recognize that, right? So you have to have these few random things that you are showing anyway, right? Where some for 10% of the users or whatever 1% of the users that are coming on your site, you are just ignoring all your models and click the first 3 random things and show that, right? And now you observe their behavior. Are they clicking on it, right? In the case of Michael Jackson, for example, that news, that was shown to about 20 people and all the 20 people clicked in the first second, right? Immediately, almost 50 to 60% of Yahoo users were seeing that news, and suddenly it became viral, right? So that power of serendipity is extremely important.
I wanted to add one one concrete example that where you find you cannot do away with humans. An example is in measuring relevance in search. Right? So let's say I'm showing results for a search query. I can't maybe with my limited read up of the literature, there's no existing way to find out are the top K results relevant to that query, right? So you develop methodologies like discounted cumulative gain or normalized cumulative gain, where you're saying, I'm going to show this results to maybe 100 people and ask each of them, say, rate the top 3 results, right? And say, is it relevant, not relevant, or is it very wrong? Right? So things like Amazon Mechanical Turk or A/B testing, which is going to measure, saying, how do I measure relevance to a search query? Google is doing that through their instrumentation through their toolbars, and they have a lot of these Mechanical Turk kind of problems where they're showing and measuring the relevance at the top K slots. So that's why I said machine learning cannot solve all the problems. It can help you jumpstart, but I can use machine learning or other stuff to probably analyze the relevance data that you've given me to say, okay, maybe every time I showed the word, maybe the word "the" is still important. Maybe it's not a stop word. I should remove it. Like those kind of stuff are still. It's going to help you.
We have time for one more question, if anyone's got a question, and then we'll wrap it.
Yeah, quick question. When I'm hearing all this, wouldn't you guys in this space in general face a lot of privacy and security issues? What's your, especially in healthcare, right? I can imagine.
Oh yes, so I think Samarth should absolutely weigh in on this one. The way I see it is, I think the problem here is one of, can you drive certain trends and patterns and detect certain things? For which you really don't need, you can anonymize the data, right? And that's how most of our customers have engaged with us too. Anonymizing is perfectly fine. However, there are certain use cases, for example, in the telco world, in the cell phone world, where they want to send you coupons. And this is an actual customer environment in the UK. There's a cell phone provider who's looking for signals from their subscribers in the tubes, in the subways, where they can, when they're waiting for a train, to send them a coupon for the coffee shop that's around the corner or the flower shop and things like that. So there is a certain level of anonymity and questions about privacy, etc. And in fact, on NPR, I've been hearing lately about Congress wanting to pass some sort of a bill around mobile phone privacy and preventing this kind of usage. But I think most people are opting in anyway because no one's really worried about this. Like going back to 15 years ago when Scott McNeely said, you don't have privacy anymore. And that was like 10, 15 years ago that he said that. So medical is a different story, but in most other environments I'm finding not only can you still do a lot of what we talked about by anonymizing the data, but even in those cases where you want to get specific and tailor-made ads or other offerings, people are opting in and don't have as much as a problem as we used to think. But I'd love to hear Samarth's perspective on that.
Yeah, I was on a different panel on healthcare data and privacy, and I was the only person on the panel who said, actually, it's not going to be a huge problem. And everybody was talking about how much of a problem it is and how much of a barrier everything is. We did an experiment at Vanderbilt University where we said, okay, we're going to sequence everybody's genome if they come in. It doesn't matter if they're coming for a cough or something else, right, cancer. 95% of the patients, they just signed everything, and they actually looked at it and said, in big letters, said opt in for gene sequencing. 95% opted in, right? If patients see the benefit of this, they will opt in. Now, the government regulations, all that need to keep pace, but I think in 3 or 4 years, when they see the power of the data, people will opt in. In the near term, it's proving a big problem for startups because they can't hook into EMRs and other systems because people are afraid of lawsuits and they're not letting them hook in and get the data, but it'll go away in the end.
I'll give you just one more quick example of this as well. The NRA, right? The biggest lobbyists for guns. So apparently, and I read about this recently, per the NRA and all the lobbyists, all the gun sellers are really not allowed to computerize the records of who they sold it to. I didn't know this before. And this I just learned recently because of the spate of bombings in schools and all that. And in fact, the people who were buying guns didn't know about this either. So there were people lobbing calls to the resellers and to the gun manufacturers really, because there's a serial number and you know who the person was who bought it, so you would think they can trace it back. But that information resides in a paper record at the seller. For example, in New Orleans, all the gun stores were completely under floodwaters. So all of those records were missing, right? So the gun, going back to the point of opting in, even the people who buy guns were assuming that that information was recorded and they were fine with it. They never once asked the question, is this information being recorded in a national database, because they assumed it. And the way they knew that these people assumed it was there is because people were calling saying, hey, I lost my gun. Do you know where it is, or where I bought it from, or how do I go back and retrace it? And they didn't know. So they wanted to report a lost gun, saying if there ever was a crime, that serial number is no longer attached to them. And when they were lobbing these calls into the police or to others, the answer they got back was, we don't have that information. And all of the gun owners were surprised and in fact astonished and disappointed too, because they were legitimate gun owners whose guns were stolen or lost. So it goes back to the point of opting in. If you know the end cause of what this is going to be, you don't mind opting in. So there's not that much of a privacy concern.
So that was good. I think I'll talk in terms of from e-commerce and from building some of these models. So traditionally we tend to, even when you're building user profiles, you tend to look at one user's activity and then you're saying, can I generalize this? But I think what you're looking for is patterns and behaviors at the aggregate level. Like, what are people commonly doing after this? An individual user ID or their name does not make any sense, right? It is irrelevant unless I'm personalizing the experience for you, like the subway example that Karthik talked about. But if I'm trying to find out people who typed in Britney this way, what was the next thing they typed? There's not much of privacy issue there. You can just look at the data at the aggregate level and compute some statistical correlations. It's just the law of large numbers at this point, right? But the place where things get a little murky is from the intellectual property perspective. Let's say, now Milind, as a data scientist, wants to say, hey, I want to run models on the eBay data. So the question is, how can I give the data to him or to any industry where they can run their models? Even if I anonymize it, I'm just probably giving away my IP or how the user behavior is. That's a much harder problem in which there's it's limited by policies, by legal rules, which even Google is not sharing all of its clickstream data. eBay is not sharing. Yahoo is not sharing. It's not like all the academicians and the professors are kind of mad because they know this problem exists. It's a very, very compelling area to work in, but they can't get access to the data, right?
So actually, AOL back in 2007 made it public, all the searches that people did on AOL search site. All that they did was basically anonymize the users who did that search with a B cookie, right? Now, obviously, you can't take the browser cookie and say this is that user, right? But people soon from there, they basically just assume that there are certain number of people that always search for themselves, right? This is self-Googling, right? And then they basically, with an accuracy of almost 60 to 70%, and that's huge, 70%, they could actually detect the people who Googled for themselves, or AOL for themselves that time. Actually then, since this was the same browser cookie that was in other searches as well, they could easily see that, oh, this person actually searched for that one as well. Why? And then basically, if you start searching, for your name, and 2 evenings later, probably you search for Viagra, you said, okay, this is the guy, right? So it's a privacy is a complicated issue, right? Even if you try to anonymize it, there are still ways to sort of decipher it based on people's behavior. But then when I look at, if you're on Facebook, and I have, a bunch of relatives, my nephews, nieces, and my uncles, everybody, all my family is there. Now, most people from India, okay? And you basically see this sort of different views on privacy from each of them. If I'm going to post something, I think 3 times as to, okay, is this going to reveal my location? Is this going to reveal that I'm away from home and somebody will come and now say, okay, this guy is not at home, so let me rob his house, right? That's what I would be thinking, right? I don't have my phone number there, I don't have my email address even there, nothing is there. And then I see the next generation is basically posting all kinds of things, where they are, who they are with, all those things, right? What privacy? I mean, the notions of privacy itself are changing completely, right? So maybe there will be a day where people will basically, and there are research on this as to, when you are talking one-on-one, you basically, keep track of, okay, what am I saying, etc. If there is a lot of crowd, everybody is talking amongst yourself, you don't care. Nobody is hearing. I mean, you're sort of, whatever you are saying gets lost in all that noise, right? Can we apply the same principles of privacy for the communication that happens around us, right? Rather than just saying one specific thing that can be pinpointed back to us, if we basically say that, throw that needle in a haystack and basically say, okay, if you're a thief, go search, you're a privacy violator, whatever, want to stop me, go search in that haystack, right? That's probably a different approach to privacy that people are going to take, right? And so much data is being created, nobody knows exactly what you know.
Good answers, guys. So we'll call it a wrap. I think we have to wrap it up here. I would love to have you guys over again. I mean, great panel. Thank you for the insights and thank you for taking the time, all of you. Appreciate it. Good night, everyone.